Okay, in exercise 8b, we learnt about this property, that if we had, if we had, a plus b multiplied by a minus b, that we'd have a squared minus b squared. That's something that we learnt about. So if we expanded that, we'd end up with this. What we're going to do today is we're going to have a look, or what we're going to do in this video, we're going to look at, we go backwards. If we've got a squared term minus another squared term, it factorises to this here. So that's what we're going to have a look at now. So, you've got to know your squared numbers. You've got to know, you've basically got to know your squared numbers. So this is referred to as difference of two squares or difference of perfect squares, dots or dops. Okay, so with this, we're looking at x squared minus 64. So hopefully you know that this x squared minus 64 is 8 squared. I'm going to put that in brackets here just so we're seeing that. So then from there, this will become x plus 8, x minus 8. Oops, did a 4. So x times x gives us x squared, x times negative 8 gives us negative 8x, 8 times x gives us 8x, 8 times negative 8 gives us negative 64. We cancel and we end up with that. Sometimes you've got coefficients in front of them. So then you've got to ask yourself, what do I do? If you can take the square root of this coefficient, then that's what you do. If you can't, you take it as a common factor. So here in this example, we should know that square root of 4 is 2. So what we can do, we can rewrite this thing as 2m all squared minus 121, which is 11 squared. So now, once again, this will become 2m plus 11, 2m minus 11. Oops, let me just write that bracket better. Alright, so this is like what I was talking about previously. We can't take the square root of 3. We can, but then we're going to end up with a surd. We try to avoid things as much as we can, like that. So what we're going to do, we're going to divide both sides by 3. So we're going to take out 3 as a common factor. So I'm going to take out 3. So now we're left with x squared, and now we've got minus, what is this 108 divided by 3? Well, we know 99 is 33 divided by 3, so another 3 lots of 3 gives us 36. So x squared minus 36. That's what we end up with there. So now once again, hopefully we know that. So we've got 3 and we've got x squared, draw the x and that squared a bit better. X squared minus 6 squared. So now what this ends up becoming is, we'll have 3, and then we'll open a bracket and we'll say we've got x plus 6, x minus 6, and we've got that sorted. Okay, last one. Now, sometimes what they'll do is they will put this here, that's a number. You can consider that as being a in this case. So here we can write this as being a squared minus 9. Hopefully we know that 9 is 3 squared, so a squared minus 3 squared, which then ends up becoming a plus 3, a minus 3, but we know that a is actually x plus 5. So what we'll do is we'll have, instead of a, we're going to multiply x plus 5 plus 3, x plus 5 minus 3. So x plus 5 plus 3 is x plus 8. And x plus 5 minus 3 gives x plus 2. If you can see that we just take this x plus 5 and put it in here straight away, that's fine. You don't have to do this bit with the a. But if you want to, you can. It's up to you. It's however you want to do it. Or if you want to leave x plus 5 all squared minus 3 squared and then go to this step, that's fine. My advice is to don't leave out do not leave out this step because then you may make mistakes. But that's how we factorise difference of two squares and difference of perfect squares.